We are live. Hi everyone, welcome back to Code Era. Today in this video we will discuss the Leetcode daily challenge for today, that is 22nd of January 2022. The name of the problem is Stone Game 5. Previously this problem has been asked in organizations like Google and Uber. It has also been asked sometimes in Amazon. So quickly consider giving me a quick +1 in the chat if my voice is audible to everyone and my screen is visible, and then within a couple of minutes I'll start with the problem. Also let me know in the comments how many of you have solved this particular problem. This particular problem can be solved using two ways, so I'll be discussing both of them. And interestingly, this problem is also a game theory problems, right? So we'll be discussing like how we'll be doing it optimally. So consider giving me a quick +1 in the chat if my voice is audible to everyone and my screen is also visible, and then I'll start right away. Okay, so I'll just wait for a couple of minutes for everyone else to join, and then we'll start with this problem. So the name of this particular problem is Stone Game 4, right? So the name of this problem is Stone Game 4, and this problem has been asked several times in Google. It has also been asked in Uber. It's asked in Amazon as well. This problem, like such types of problem, are also very popular in organizations like DSHO as well, right? Because those organizations are also the organizations that check your problem solving capacity or skills, right? So now talking about this problem, what it says is that Alice and Bob take turns playing a game with Alice starting first. So Alice is starting first, right? Alice will start first and take turns playing a game. So what happens, initially there are n stones in a pile. There is a pile, so there are total n stones initially, and one player each time one player will be taking a turn alternatively. And what you have to do is you have to make moves consisting in which you have to remove any non-number any particular number of stones from that pile, such that the number of stones that you are removing, it should be a perfect square, right? Let's say if I had 60 stones, right? If I have 60 stones, then what I can remove, I can, let's say, remove 25. I can remove 25 from this. Why? Because 25 is a perfect square, right? So after that it might be left with it might be left with 35 stones, right? If let's say I had 50 stones, okay, in that case what I can do is I can, let's say, remove 16 stones from it, right? Because 16 is a perfect square. In that case how many will be left? 15 minus 16, so that will be some number, right? After that, let's say if I had 20 stones, then I could also remove how much? I can also remove let's say I can remove 9 stones from it, because 9 is a perfect square. So are you getting this part of the question, that every time you have to remove, every time you want to remove some number of stones, so that should be a perfect square. So that means it should basically be like this. Let me draw and tell you. Okay, it should be something like this. It should be a number like 1, because 1 is a perfect square. It can be 2, it can be something like a 4, it can be 9, it can also be 16, it can be 25. Numbers like these. So that are numbers that are perfect square. If this much part is clear, please write clear in the chat. If this much part of the problem statement is clear, please write clear in the chat, right? Now next up, starting with this question, right? Shall I start with the question, like how you have to do this in game theory format? So if my n is given to be 1, okay, so if n is given to me 1, so I have been given one stone, right? So what I can do is I just directly remove that particular stone. So that means how many stones can I remove? Can I remove 1 stone from it? Yes, because 1 is a perfect square. So what happens is Alice comes and Alice removes 1 stone, right? So after that you are left with 0 stones, and then there is a chance of Bob. When Bob comes in, so he will not be able to take these stones anymore, because that is not possible now, right? That is not possible now, because in this case what is happening, there are 0 stones, so he cannot take any stones further, right? I hope that this much part is clear. Now next up, if n is equal to 2, in that case what would happen? If n is equal to 2, then what are the chances, what are the conditions, or what are the situations that I can have? So if I have 2 stones, so Alice has to remove 1 stone, at least she has to remove whatever number of stones she can do, so that she can take a chance, right? So that's why what she will do, you have 2 stones, so either you can remove 1 stone or you can do nothing, right? But you will remove one stone because 1 is only a perfect square. Up to, from 1 to 2 up till that number, you have only one which is a perfect square, right? So that's why you remove one stone. So Alice removes one stone, and after that what happens? After that you have one stone left. You have one stone left. So now Bob comes in, and Bob does what? Bob removes this particular stone, right? Bob removes this particular stone. So Bob removes this one, and after that you are left with 0 stones. So what happens? You are left with 0 stones, and then Alice comes in. So what will happen? Alice will lose because Alice, the number of stones left is 0. So Alice will not be able to take any stones further. So that is why she would lose, right? I hope that this much part is clear. Now let's suppose that if n was 3, then what would happen? If n was 3, then there would be several situations that we need to talk about, right? If n was 3, so in that case, if I had 3 stones, right? If I had 3 stones, so in that case, what could have happened is, let's say Alice takes out one stone, right? Alice takes out one stone. So after that 2 stones are left. Then Bob comes in. Bob also takes out one stone, right? Bob takes out one stone. So one stone is left in the pile, right? This is the pile. This is the pile that we have. After that, what will happen? Like this will become what? Alice comes in again, and Alice will take one stone again from here. So this becomes 0. So that means that now Bob will come in and Bob will lose. Bob will lose because he will not be having any further stones to take out, right? Is this much part clear to everybody? I hope that this much part of the problem is clear, right? So that is why if n is equal to 3, then Alice wins, right? Now let's check for the condition when n is equal to 4. Like this is in case of game theory, you have to run it for several test cases, and only then you'll be able to figure out like what's the optimal situation. So if n is equal to 4, can I say that this is nothing but a perfect square? So in that case, Alice will be starting first. So since n is equal to 4, that is 4 is a perfect square, that is 2 into 2 is equal to 4. So that's why you will say that okay, Alice wins, right? Alice wins. Now let's check it for 5. If n is equal to 5, in that case, what would happen? If n is equal to 5, then there would be several situations, right? If n is equal to 5, in that case, either Alice can pick one stone or she can pick 4 stones, right? This is something that she can do. Is this part clear to everybody? If there are total 5 stones, then in that case Alice has 2 situations, because now then since the number is 5, so you have got 2 perfect squares from 1 to 5. One is the number 1 and another one is the number that is this number, right? So is this part clear? So what will happen in case of 5? In case of 5, what would happen? In case of 5, I will say that if Alice picks up one stone, right? If she picks up let's say if she picks up 4 stones, right? So in that case, one stone would be left. If she picks up let's say one stone, right? In that case, 4 stones will be left. So if she picks up 4 stones, so 1 stone will be left, and if she picks up 1 stone, then 4 stones will be left. So what will happen? This is the chance taken by Alice, right? This is the chance that is taken by Alice. Now when Bob will come in, so if she picks up 4 stones, then Bob will have 1 stone and he can directly pick this up, and the number of stones in the pile will be left will be 0, right? Another thing that could happen is that let's say you pick 1 stone, right? Alice picks 1 stone. In that case also 4 stones will be left, and since 4 stones are there, so in that particular situation, what would happen? Basically Bob will be able to pick it, and when Alice will come back, so she will not be able to pick any stone. So that is why Alice will lose. So if n is equal to 5, then Alice loses, right? If this much part is clear to everyone, please consider giving a +1 in the chat, and then I'll explain the problem further, right? How you can develop a game theory approach for this one. Okay, now let's try and make an array and see what will happen. Basically what we are trying to do is, let me draw this first. Okay, right, this is 1, this is 2, this is the 3, that is n values. This is the various n values that you will be having. Hi Aniket Yadav. So this is nothing but 4, this is 5, then this would be 6, this would be 7, this would be 8. Let's take it till 9 or somewhere, we will observe. So if n is equal to 1, if Alice will win, then I'll write true in this particular array, otherwise I'll write false. Okay, so will Alice win if n is equal to 1? Yes, Alice will win. If n is equal to 2, in that case, who will win? If n is equal to 2, in that case, what will happen? Alice will first pick 1 stone, and then 1 stone will be left, so Bob will pick it and Bob will win. So that is why Alice will not win in this part if n is equal to 2, so I'll write a false. If n is equal to 3, in that case, what will happen? If n is equal to 3, In that case, what will happen? Alice will pick one stone, then Bob will pick one stone. So total one stone last in the end will be left. So Alice will pick the last stone. So that is why Alice will win. So I'll write true for it. If n is equal to 4, so for every perfect square, like if you have 9, so in that case also you will write true, because Alice will come and directly pick the perfect square number, right? If n is equal to 4 also, then you will write true. What if n is equal to 5? What if n is equal to 5? That is the situation. Let's see what we observed there, right? If n is equal to 5, we have already discussed this part with you. If n is equal to 5, in that case, what are the probable situations? Either I can pick one stone, either Alice can pick, Alice will start first, so Alice can pick one stone, or Alice can pick 4 stones, right? So if she picks one stone, then 4 stones are left. If she picks 4 stones, then also then one stone is left. Now the Bob's chance will come here, right? Bob will be left with this. Bob will come, and these will be the situations. If she picks one stone, then 4 stones will be left. In that case, this is a perfect square and he will win. So she will not try to pick this up. But what if she picks up this? If she picks up 4 stones, even then there is one stone left, so 1 is a perfect number. So that is why Bob can also pick this and Bob will win, right? In the end, no stones will be left, right? So that is why can I say that if I take even one stone, or if I take 4 stones, so in the chance, if Alice is taking one stone or if Alice is taking 4 stones, so it does not matter, because ultimately she will be losing. She will be on the losing end. If you agree with me, please write yes in the chat. Please write yes in the chat if you all agree, right? So that is why I'll say that for 5 I will write a false. If someone is having 5 stones, in that case they have to lose, because there is no chance to win, right? I checked for all the opportunities and there was no chance to win, right? I hope that this part is clear. Now let's move to 6. Now let's move to 6. Now this is the game theory part that we are doing. I'll be explaining like how we'll be translating this thought process into the code as well, but let's do more iterations. What if n is equal to 6? If my n is equal to 6, in that case, what can be the situations? In that case, I can what are the perfect squares that I have? I have 1 and 4 as the perfect squares that I can pick, right? Either I can pick 1 stone or 4 stones. That is what Alice can pick. So let's start with this. If I have 6 stones, so if Alice picks 1 stone, right? If Alice takes 1 stone, right? Or if Alice takes what? 4 stones. So let's see what will be the situations. Ultimately, you want to win. Every player will be playing this optimally to win, both Alice and Bob. So what will happen? I have indicated this yellow for Alice, and let me write this white for Bob. Okay, white will be for Bob and yellow will be for Alice. So Alice picks up 1 stone. If Alice picks up 1 stone, then how many stones will Bob be left with? Bob will be left with nothing but 5 stones. Okay. And what if Alice picks up 4 stones? If Alice picks up 4 stones, then Bob will be left with 2 stones. So what is better? Right? This much part must be clear. If you have 6 stones, so either Alice can pick in perfect squares. Either Alice can pick 1 stone or Alice can pick 4 stones. Notice this, right? Either she can pick 1 stone. So if she picks 1 stone, so Bob will be left with 5 stones, right? Bob will be left with 5 stones. If she picks up 4 stones, then Bob will be left with 2 stones. Now what should she pick? Should Alice pick 1 stone or should Alice pick 4 stones? Please write in the chat. What do you think? What should Alice do? Should Alice pick up 1 stone or should Alice pick up 4 stones? Let me know in the chat. Quickly let me know in the chat. What is your observation? What is your opinion? Like, should Alice pick 1 stone or should she pick 4 stones? Quickly comment down below. Aniket Yadav and others, please comment down below. What do you think? How much stones should Alice pick? Should she pick 1 stone or 4 stones? Just think about it a little bit. 1 stone. Why, Aniket Yadav? What's the reason? You can also let me know that. Okay. Let's say if she picked 4 stones, right? What now? These are the winning states, right? This array is nothing but winning state array. This is a game theory concept. Let me write it. Right, let's write it. If this might be something new for some people, so let's see what are the winning states. Right, these are the winning states. Now this will be nothing but a bottom-up approach. This will be a DP kind of approach. Will maybe be bottom-up. Now you can see that if Alice picks 4 stones, then Bob will be left with 2 stones. And what happens when someone is left with 2 stones? What happens when someone is left with 2 stones? If someone is left with 2 stones, if someone is left with 2 stones, he will not be picking 4 stones. Alice will not pick 4 stones. Like Alice can pick both. That will depend. Let's first try to figure out this, right? If Bob picks up this, if Bob is left with 2 stones, so if someone is left with 2 stones, then in that case it is written false. So that means that you will win. If Bob is left with 2 stones, so for 2 the array says that it is false. So that means if you pick 2, then in that case you will lose. If someone is left with 2 stones, so that in that case the array is indicating that he or she would lose. So that means if you pick 4 stones and 2 stars left, then Bob will lose, right? Bob will lose. And what if you pick up, if we are at index n, we choose, yeah, right, that is also correct. I'll be explaining this part using the square root part, right? Okay, after that, what could happen? Assume that if she had to pick, now let's assume that you picked, Alice picked 5 stones. If Alice had picked 5 stones, Alice picked 1 stone, then you are left with 5 stones. If someone is left with 5 stones, so we have already discussed this particular state. That if someone is left with 5 stones, then he or she cannot win, right? Because with 5 stones you cannot win, because you will do what? You will, if you pick 4 stones, so in that case the other person would be left with 1 stone, so he or she would be able to pick up and your turn would not come. If you have 5 stones, if you pick 4 stones, then you will be, if you pick 1 stone, then 4 stones will be left. In that case also other person would be able to pick, so in that case you will not win. So that means whoever person is left with 5 stones, he or she would lose. Please write clear in the chat if this much part is clear, or please write +1 in the chat, right? Is this much observation clear to everyone, right? Now let's stimulate further. So what can I say? I can definitely say that, what do I mean? Should I write true for 6 or should I write false for 6? Please comment down below in the chat. What should I do? Should I write a true in the in this 6, or should I write false? Should I write true in the place of 6? Should I write here true or false? What should I write? What should I write? What should I write? If I pick 6 stones, if I'm left with 6 stones, so that means if I pick 5 stones, what will happen? Should I write a true or false? Why true? Aniket Yadav, let me know. Why true? I'll write a true, but why? What's the reason for that? The reason is that if you are left with 6 stones, then there will be an opportunity that either you can leave 5 stones for the other person or 2 stones for the other person. So other person loses, right? Other person loses. So that means if you have 6 stones, then you win. If you are at the state 6, if you have n is equal to 6 stones are there in the pile, so in that case either you can leave the other person with 5 stones or you can leave the other person with 2 stones. In both of the situations, like, the other person will lose. So that means you will win. If you have 6 stones, so that means you will choose optimally in such a way that you will leave the other person with such amount of stones such that he will be in a losing state. That is why you will be in a winning state, and we are discussing that only. We are updating the array according to that if you have this much number of stones, then will you win or not, right? So that means you will write it true for this, because if you have 6, then you will leave the other person with either 5 stones or 2 stones. In that case other person would lose, so that means you will win. So that's why you are updating it with true, right? Now next up, what will happen? Next up, let's discuss this further. Okay, if we win by some, then we assign true. Yeah, right. Perfect. Now let's discuss it for n is equal to 7. I'll just stimulate it till 9 and then I'll be showing you the code part for this particular problem, right? Let's do it for 7. So what happens when I have 7? I can say that either Alice can pick 1 stone, right? This will be the chance for Alice, right? Either I can pick 1 stone or I could pick 4 stones. So if I pick 1 stone, then I'll be left with 6 stones. If I pick 4 stones, then I will be left with how many stones? I'll be left with nothing but 3 stones. So what happens? Alice will try to pick the stones in such a way. Alice will try to pick that stone such that the number of stones left for Bob is such that he will be in a losing state. So if Alice picks 1 stone, then 6 will be there. Then Bob will be at n is equal to 6. In that case, Bob will not be able to win. No, in that case Bob will win, because at 6, If someone is at the state 6, if n is equal to 6 for someone, then in that case it is written true. So that means if Bob gets 6 number of stones, he will win, as we have discussed already, right? So if Alice picks 1 stone, then Bob will land at 6. In that case he would win. So that is not something that Alice will try to do. Let's discuss for this case. What if Alice picks up 4 stones? If Alice picks up 4 stones, then Bob is left with 3 stones, right? Notice that these are only the 2 opportunities that can happen. So Bob is left with 3 stones. So if Bob is left with 3 stones, in that case what will happen? If someone is left with 3 stones, right, Bob will be left with 3 stones. In that case he would win, right? So that means that if you are at a state such that your n is equal to 7, in that case, irrespective of the fact that whether you leave 6 stones for the other person by choosing 1 stone, or you leave 3 stones for the other person by choosing 4 stones, in both the cases you will lose. So can I say that I will write false for this? Please consider giving a +1 in the chat if this much part is also clear to everyone, right? Is this clear to everyone? Please consider giving a quick +1 in the chat. I hope that this part is also clear, right? Now let's do it for 8 as well. Right? Let's do it. So what will happen when n is equal to 8? Let's do it. So when n is equal to 8, let's try and iterate for it. Okay, you can let me know. So if I have 8, so either Alice can pick 1 stone. Please write a +1 in the chat if this much part up till now is clear to everyone, right? If up till now everything is crystal clear, so please write clear in the chat. Okay, either I can pick 1 stone or I can pick 4 stones. Alice can do this, right? This is what Alice can do. Either Alice can pick 1 stone or Alice can pick 4 stones, right? Because these are the perfect squares that she can pick. Okay, hi Abhishek Shukla, thank you for your feedback. Okay, after that, if Alice chooses 1 stone, then you will be left with 7 stones. That Bob will be left with 7 stones, right? If Alice chooses 4 stones, then Bob will be left with 3 stones. So how many number of let me know how many number of stones will Alice choose? Let me know. Will she choose 1 stone or will she choose 4 stones? What will she do? Please write in the comments. Will Alice choose 1 stone or will Alice choose 4 stones? What will she do? What will she do? She will choose. If she chooses 4 stones, then in that case the state 3, Bob will land at state 3. If Bob lands at state 3, in that case this is written as true. If someone is landing at state 3, then it's written true. So that means Bob will win. So this is not something that she will want. She wants to win for herself. So that is why she will not choose this. She will not choose 4 stones such that Bob lands at the situation as n is equal to 3, because at n is equal to 3 there is a winning state, right? So that's why what will happen? You will say that Alice will choose 1 stone, because if Alice chooses 1 stone, then 7. What about 7? 7 is a losing state. Bob will be left with n is equal to 7, and 7 is what? 7 is written as a losing state, right? 7 is written as a losing state. 7 is written as false. If 7 is written as false, so that means that whoever is coming at 7 will lose. So that means if Alice picks up 1 stone, then Bob will be left with 7 stones, and that is why she will pick 1 stone, so that Bob comes at the state n is equal to 7. So that is why 7 stones will be left, and if 7 stones are left, that means that the other person, the person coming to this n is equal to 7 state would lose. So if the samne wala loses, then you win, right? That means if Bob loses, so that means Alice wins. That means you win. That's why you say true, right? I hope that this much stimulation was clear. Now what do you say about this approach, right? I hope that this winning state array is very much clear to all of you. Please consider writing a crystal clear in the chat. Please write a crystal clear in the chat if this much part is clear, right? Now this is nothing but a winning state kind of array that I've made, that whether that particular state is a winning state or not, considering for all the values of n. That is what I've tried to do. So what I've tried to do, this is nothing but a bottom-up approach, right? You are trying to build for the smaller ones. You are trying to build for the smaller values such that you can find the bigger value, that is for the original value of n that has been given to you, right? Whatever is the value of n that has been given to you, you are trying to build the smaller blocks such that you are going from bottom up. This is nothing but a kind of bottom-up approach, right? Can I say that this is nothing but a bottom-up approach, right? You can also say that this is a tabulation approach, right? tabulation approach. Right, this is a tabulation approach or bottom up approach. I'll also discuss the top down approach, that is recursive DP, as well for this particular problem. Now what I can say is that let's say if my n was 20, if let's say my n was, let's say 24, in that cases what are the opportunities that I would be having? I could have picked one stone, or I could have picked 4 stones, or I could have picked 9 stones, or I could have picked 16 stones. So can I say that for a particular number n, I can pick until under root of n stones, right? So that means whatever are the perfect squares, I'll keep on storing them. I'll keep on storing the perfect squares so that I can find that whether it will be optimal for me or not. Okay, shall I show you the code part for this? I will show you the code part for this, right? So what I've basically said is let's look at the code, right? Let's look at the code for this particular approach that I've discussed with all of you. So this is the approach that I've discussed. First of all, what I've done is right. What I've done is I've declared a vector. I'll be given n. I've declared a vector in which I'll be storing all the perfect squares, because I'll require those perfect squares when my game would increase. So in that case, I will not be like, if n is 8, then I can say that okay, I'll pick 1 or 4. But if n is larger value, then in that case I need to have all those perfect squares in my vector, so that I can always keep on checking, right? I can check it in under root n time by iterating through I do not have to generate all the perfect square up till that number, right? So what I would do is initially the perfect square is 1. Okay, I'll say that this is the result array. So this is the winning state array. This is the winning state array that I've made. What I'll do is result of 1. If I have 1 stone, then I know that I win. So I'll mark it as 1. If I have 2 stones, then I will lose. We have discussed this already. So I'll mark it as 0. If I have 3 stones, then I'll mark it as 1, indicating that I'll win. Right, I've discussed this. You can move back and watch. Please give me a +1 so that I know that everything is going crystal clear, right? Okay. If now what I'll do, I'll start the iteration from these are the nothing but initialization, right? You fill the table, right? You fill the table. So initially for some states you will be able to find it. Now you start from I is equal to 4, I is lesser equal to n. So this is what you are doing. You are filling the table for all the n states. For all the n states you are trying to fill. So what you will do is, first of all, you will check what? You will check for the perfect square condition, right? You will find the square root of the ith number. You will find the square root for the ith index. If the square root that you have found for a particular number, this is nothing, you are storing an int, right? So if 16 is there, then square will come out to be 4, and 4 into 4 will give me again 16. If I is equal to 16, then in that case sq will be 4. So that means 4 into 4 would give me 16. So that indicates that yes, that will be a winning state directly, and that is what I said. All the perfect squares, I'll be marking them as 1, and I'll be storing them in a vector. So that is ith state I'll store in a vector, right? If this much part is up till now is clear, please give me a +1 in the chat. Now next up, another thing that I need to notice is that what if this is not a perfect square? If this is not a perfect square, then I go to the else part. Because if this is not a perfect square, then I will not mark this particular state as true. Now I have to check for the intermediate states. So what I will do is I'll mark an OK as 0. If up till now everything is clear, please give me a +1 in the chat, because only then I'll be able to proceed further. Right, up till now everything is clear. Please give me a +1 in the chat. Like Aniket Yadav and Abhishek, all people, please give me a +1, right? Okay, perfect. Now what I'll do is I'll mark an OK as 0, indicating that I will initially I'll think that I might lose. So I'll mark my OK as 0, indicating that I'll be marking the present state as false. Now initially I'll think that I will lose. If I win, so I'll mark it as true. So I'll see. What I'll see is I'll iterate through the complete array. This is what array? This is the array of perfect squares, right? This is array of perfect squares. In this, the states will be stored. Like Alice can take how much? Either Alice can take 1, Alice could take 4. Right, Alice could take 4, so vector would be storing these numbers. Like vector would store 1, then it would store 2. Like I have kept it storing, like all the perfect squares are stored in it. So after this I have, let's say 9, well then I have 16. As I keep on moving, so all such numbers will be there, and that is what I was checking. And if for a particular state, what is the difference? What is I minus vk? If I, let's say I was this, let's say if my I was 7, or let's say if my I was 8, in that case, if my I was 8, then in that case what are the values that I have in vector? I have 1 and I have what? I have this value 1 and 4, right? So that means v of 0 is 1 and v of 1 is 4, right? So I'll see I minus, what is the state for I minus, that is I'll check in the vector what is the state of I minus v of 0, right? So that means what is the state of 8 minus 1, so that is 7. So what is the state of v of 7? V of 7 is indicating false. So that means the moment I see that at a particular state I go and I find a false at this particular state. So if that means that if this particular state, basically I'm checking for all the differences, right? I minus vk is nothing but the, what if I pick vk number of stones, that is nothing but vk is the perfect square, a perfect square. So I'll be checking for all the vk's in this. So vk is the perfect square. So I minus vk is what? I minus vk is, if I pick vk number of perfect square stones, in that case I minus vk will be left. So is this particular state, if this particular state is the number of stones that will be left for Bob, if this particular state is losing for Bob, so that means it should be 0. If this particular state is for Bob and it is losing, then it is 0. In that case I will win myself at this particular ith state. So I'll mark it as 1 and I'll say OK is equal to 1, indicating that OK, I have found a winning state in this, for this particular number, for this particular I have found a winning state, and I'll simply break from the loop because this is the loop of the perfect square. So I'll break from it. After that, if my OK is equal to 0, so that means that I haven't found any winning state. If I travel through all the, if I travel through all the situations, like how many number of stones I can pick, this much or that much, you can also like the video I am explaining a little bit with detail. Okay, so if my OK is equal to 0, indicating that I haven't found any winning state, right? For like I cannot pick any such perfect number of perfect square number of stones such that the number of stones left for Bob makes him land into a losing state. In that case, he will be in the winning state whenever I pick a perfect square number of stones. So in that case, I have my OK as 0. So I'll say that I cannot win in this particular state. So I'll mark my result of I as 0, right? This is what I would do. It's not necessary that you do this. Like you can also mark all of them as 0. Like you can also do this thing. You can also like remove this part and initially you can mark your result as 0. That will also work, right? In the end, I'll simply return result of n. In the end, I simply return result of n. That is the nth state, the position of the nth state, whether Alice is going to win or not. If Alice is landing at the nth state, right? Alice is landing at the n number of piles of stone, n piles of stones. So will she win or not? That is stored in the result. If this much part is clear, please write clear in the chat and then I'll move to the other part, right? So this was what? This was a bottom-up approach, right? The first approach that I have discussed, it's a bottom-up approach. Bottom-up approach, right? And in this particular approach, one thing that you can observe is for this particular approach, this is also known as tabulation in dynamic programming kind of things, right? Also, one more thing, like you are running a loop of 1 to n for checking for all the states, right? For filling your array, for filling your winning state array, for determining the winning state of a particular n, you are running it. So that is why the outer loop complexity is order of n, and the inner loop is running what? The inner loop is running from, like, for variables like 1, 4, 9, all these values. So that means for all the perfect squares, so that is nothing but order of n. There will be order of root n perfect squares. If n value is 100, then the highest perfect square would be 10, right? So that's why it will be under root of 100. So that is the largest if n value is 100, right? So under root of 100 would be 10. So that is why the inner loop will run at most this much number of times in the worst case. So that is why the overall time complexity of this particular approach would be order of n into root n, right? So this will be the time complexity of this particular approach. Please write clear in the chat if this much part is clear to everyone, right? I hope that it's clear. Now let me discuss about the other approach as well, right? I hope that this approach was clear. Now let's discuss further. Now if you have understood it, then that's perfect. But another thing that you can do is approach number plus root n. No, you will multiply it. It will be order of n root n because it is running inside, right? So that's why it will be order of n root n. Okay. After this, another approach number 2 could be that you use the top-down approach. Okay, top-down approach. What do I mean by top-down approach? So you use a top-down approach. Basically, I'm indicating, yeah, n to the power 1.5. Yeah, that's perfect. Like n to the power 3 by 2. Like n into root n would be nothing but n to the power 3 by 2, something like this. Okay, so that's nothing but n into root n. That's also called like that. Okay, so if let's say I had 8 stones, right? If I had 8 stones, in that case, what will happen? if I pick one stone, then in that case 7 stones would be left for Bob, right? If I had Suppose if I had picked 4 stones, in that case Bob would be left with how many stones? 4 stones. So I know that this part would be okay, right? So initially what I could say that if my n is equal to 0, in that case I will be on the losing state, like I will lose. I have told you this. So what if n is equal to 1? Let me try to stimulate this very quick, a little quick. If n is equal to 1, then what will happen? I will win. I'll surely win, right? I know that, because for the other person it will be n is equal to 0, so the other person would lose. If n is equal to 2, then I know that I have 1 and I'll pick 1, so that is why 1 stone will be left. And I already must have stored in my dp that dp of 1 is equal to what? Dp of 1 is equal to true. So that means that the moment Bob will land at this particular position, so he would win, right? This is what I would do. Now let's say that if I had n is equal to, let's say, 7. So if I had some situations like this, so what would happen? If either I could pick 1 stone, or either I could pick let's say stones, 4. So if once I pick 1 stone, then Bob will be left with how many stones? Bob will be left with 6 stones. If I pick 4 stones, then Bob would be left with how many stones? 3 stones, right? So these would be the situations. Now let me stimulate this further. Let me stimulate this further. So I hope that this part is clear, right? Like you are just doing a recursive approach. Like from n, either you can go to n minus 1 or n minus 4, or if n is a greater value than n minus 9, something like this. Okay, so if my n is lesser equal to 0, in that case I'll say that okay, I'll be on the losing state, right? I'll lose, because if n is lesser equal to 0, so that means either I have negative or I have 0, so that means I'll never be able to win this situation, right? So this is what I'm trying to do. Like, you know that I would be storing all the states, right? So what I could do is, another thing that I need to notice, that if I have 17, then either I could pick 1 stone, I could also pick let's say 1 stone, or I could pick 4 stones, or I could pick something like a 9 stones, or I could pick 16 stones, right? So if I do it this way, so I'll be left with 16, I'll be left with this as 13, and I'll be left with this as nothing but 8. I'll be left with this as 1, right? So these are all the states. Now I know that 16 will also have a subtree of itself, right? 16 will also have a subtree of itself. So can I say that if my n is equal to 16, like this is the recursive state that we are doing. I hope that this much part is clear, right? So if you have 16, then in that case what you could notice is that you have 1 stone, or you have you pick 4 stones, or you pick something like 9 stones, right? Or you pick directly 16 stones, like this. Like let's discuss this, right? If you had 13 stones, then 13 will have a subtree of its own, right? Either you pick 1 stone, or either you pick something like 4 stones or 9 stones, right? So if 13 is there, 13 must have already been pre-calculated in my dp. 13 must have been already calculated. So if I come to this 13, so I don't need to calculate it back, right? I'll simply return the answer for this particular thing, right? So let me show you the code part, like how I'll be implementing it recursively. What I will be doing is, I'll be marking all the dp states as -1 initially. Then in the answer I'll be storing what is the answer that's coming from this particular function. So if my n is lesser equal to 0, in that case I'll return a 0. If the nth state is not calculated already, in that case it would if it is not calculated, then it will be equal to -1. But if the nth state is not equal to -1, in that case what will happen? I'll simply return dp of n, because it would already be calculated. Then what I'll do is, I'll try to figure out all the situations. So this is something I'm calling recursively, that I'll try to figure out for all the possible squares, that is number that I can pick. If there are n stones and I pick all the perfect squares, so I can pick I, like I, that is 1. For I is equal to 2, I can pick 4 stones, so that is why I cross I, that is 4 stones if I pick. Then for I is equal to 3, I can pick n minus 9 stones, right? So that is all perfect squares that I'm picking. So if that particular recursive state makes me 0, if that particular states, so if I pick I square number of stones, right? I am picking always perfect squares. So if I'm doing this, if I'm always picking perfect number of squares to stones, so that is why the other person would be left with n minus I square number of stones. And if that particular state, if this particular function returns a 0, in that part, this particular state would be a losing state for the other person. So that is why I'll mark this state as a winning state for myself, right? So that is why I'll return a true for this. And in the end, if I'm never able to find any situation in this loop, if I never return a 1 from this particular function, from this particular loop. So that means that I'm never able to find a winning state for myself, right? If I'm never able to find a winning state for myself, in that case I'll return a 0, right? Because I'll be, if this state comes to me, then I'll be on the losing end, right? So I'll mark it as a dp of n as 0, right? If this question is clear to everyone, please write clear in the chat. And now looking at the approach and everything for this particular question, you must have understood that why this question was previously asked in organizations like Uber. It was also asked in Google, and it was also asked sometimes in Amazon. Also, it can be asked in companies like DShow and other companies, or media.net also. So consider giving me a quick +1 in the chat. I am just waiting for 60 seconds for taking your doubts or any feedback that you have, and then I'll be ending this stream. Also, you can check out our channel like Codera. On this channel, like you can see, I'm doing daily the live streams of Leetcode problems. Today's Leetcode problem was a little hard, but I tried to explain it in the best way possible. Like you can see, we are doing it today. Also, we'll also be doing codeforces round as well. So you can subscribe our channel for that, and we are pushing in a lot of content on this channel, trying to build a community. So if you like the content that I have done, so make sure to like the video and also give us a +1 in the chat, and make sure to subscribe the channel. Thanks a lot everyone for watching, and I'll see you soon in the next